Hello and welcome to the tutorial video for Acadec Math Focus Quizzes 15 through 17. There are 3 quizzes. I don't think they're that bad. There's like 1 or 2 questions per quiz that might give you some trouble even if you understand it, but you should get through the rest of them quickly enough that it won't destroy you. You'll have time. The quizzes are areas and properties of polygons, which is probably the roughest, prisms, and cylinders, and those are extremely similar, so shouldn't have too much of a problem there. Okay, here's stuff for polygons. Several parts of it are very easy. This part is it's not hard, it's just you have to memorize that. I spent quite a while, like literally an hour and a half, trying to figure out a way to use the Inspire to not have to memorize this. Couldn't find an easier way, honestly. Not a quicker way than just memorizing this. Not an easier way. It just becomes this huge trigonometry problem that you don't want to do, and it boils down to this eventually. So try to memorize this. Do that little quadratic formula song. Make one up for this. Good luck. Okay, so you know what the majority of polygons, and they're also called n-gons for some reason. So if you see n-gons, it just means polygon. A lot of these you know: 3 sides triangle, 4 sides quadrilateral, pentagon, hexagon. 7 sides is a heptagon, 9 sides is a nonagon, and 10 sides is a decagon. All right, hep means 7, non means 9, 10 means dec, or dec means 10. You know what I mean. So those memorize, I guess. If you already know them, cool. But they will come up in a question, and they will not tell you 7-sided heptagon. They'll just say heptagon. You have to know it's 7. So, first equation, sum of the angles of a polygon. So you probably know that a triangle has the 3 angles, and they will always add up. So the sum of them is 180. And that makes sense because n is the number of sides. All right, for all these equations, n is the number of sides of a polygon. So for that triangle, it's 3. 3 minus 2 is 1 times 180. The sum is 180. Say in a square, in a quadrilateral, there's 4 sides, so 4 minus 2 is 2 times 180. The sum of all the angles is going to be 360, 2 times 180. And that goes for all of these. You just subtract 2, multiply by 180, and you will get the total sum of the angles. And a lot of the problems are as simple as that. How many sides does this have? What's the angle measure? And/or they'll give you the angle measure, ask you, how many sides does it have? This is the equation for the number of diagonals in a convex polygon. I could not find any reason that convex or concave really mattered. It really doesn't. It shouldn't affect the number of diagonals. I suppose it would if you don't let them cross over other sides. If there was a concave one, maybe that would mess up. Regardless, pretty much just number of diagonals in a polygon is this n times, inside parentheses, n minus 3 over 2. So for a triangle, there are no diagonals, right? Because the n minus 3 becomes 0. And that makes sense. You cannot go to another point without just tracing the triangle. So triangles have no diagonals. However, a square is the first one where we'll have some. And we have 4, let's fill it out right here, 4 times that 4 minus 3 is going to be 1 over 2. So that's just going to equal 2. And that makes sense because we have 2 diagonals we can make. And that applies to all of the polygons. For 5, it becomes 5 different diagonals. I'm not going to try and draw that, make you see it. Just memorize this equation. This last one, I'm just going to show you one example problem with this. Because look at that, it's kind of a doozy. If you have this memorized, cool. The other way you do this is every regular polygon, because that's only what this applies to. Every regular polygon can be split into equilateral triangles, and if you have this side length S, you can split here. It's a 30, 60, 90 triangle. Then you can find this length, and then you can do a different equation with this length, which is called something special that starts with A, apoium or some. I couldn't tell you. And you find that length, and then there's another formula to throw it into, and that is the only other way I could find to reliably do that. I tried to use some of the special little shape tools in the calculator. Didn't work. Not consistently anyways. So you just have to memorize this for now. And then plug it in. So we'll see that. The only two variables in here are n, which is the same. It's the number of sides. So just so you can write this down, n is number of sides. So for a nonagon, it'd be 9, right? Example. And s is side length. Assuming it's a regular polygon, it's the only side length because they're all the same. Regular polygon just means that every side length is the same. Don't know if I said that yet. So a square is a regular polygon every time. Okay, so about as simple as it gets to start with. What is the sum of the angles of a heptagon? Hep is 7, right? And our equation is n minus 2 times 180. So 7 minus 2 is 5 times 180. Not doing that in my head. 5 times 180. 900. So the sum of the angles in a heptagon is 900 degrees. And all of these we'll be doing in degrees, not radians. I don't think you have to mess with radians. You might later, but for this, it's all degrees. Find the number of sides of a polygon if the sum of its angles is 2340 degrees. All right? So our equation, again, is n minus 2, and this is what we're going to be solving for, times 180. In this case, it's going to equal 2340. And you could end solve this. I think it's quick enough to just do the algebra that you probably, oh my goodness, probably shouldn't. So you can divide that by 180. So 2340, right? Yeah. Divided by 180 equals 13. So then n minus 2 equals 13. Plus 2 on both sides, n equals 15. Not too bad, right? And then if we plug this back in, you would get 2340, just to check. How many diagonals does a convex nonagon have? So a nonagon is a 9-sided polygon. Again, I don't think that that convex does mean something relevant. Don't worry about it too much. If it says concave, it behaves about the same way. I don't think it matters, honestly, but maybe. We'll go over that, but it doesn't matter on this quiz, anyways. How many does it have? So our equation for that was n times n minus 3 over 2. Can we make sure that is the case? Yes. Okay, so we can plug it in. We know we have 9 sides. So 9 times 6, which is 9 minus 3, over 2. This is 54 over 2. And that is, what, 27? Let's see if I did that correctly. 9 times 6 over 2, 27. Cool. So 27 diagonals you can make in a 9-sided polygon, which would be really annoying to have to just draw and do. So this formula is useful. If a convex polygon, n-gon, has 65 diagonals, find n. So now we have n times n minus 3 over 2 equals 65. Now here's the deal. You cannot n solve this because this becomes a quadratic equation. Okay, and as such, it has 2 answers, and it could, the n solve will only spit out the first answer. It could very well give you the correct one, or it could give you the incorrect solution. If one of the solutions of the quadratic function is negative, it could give you that first, and that is not correct. You can't have a negative number of sides. So we have to simplify this to solve it like a quadratic. So we multiply both sides by 2 to get n times n minus 3 equals 130, 65 times 2. Then we'll distribute these. We'll get n squared, it's like this. N squared minus 3n equals 130, but we want that 130 over here so we can have it equal 0. So we can plug this into our calculator, and it will tell us the 2 solutions. So the way you solve a quadratic in the calculator, if you haven't done it before, it's very similar to nsolve. Menu 3, but instead of nsolve, we're going to go to polynomial tools. And then, I think I accidentally clicked twice, but click find roots of a polynomial, degree 2, real. Just scroll down and make sure you don't change that to 1. Make sure you leave it at 2. You can just move the cursor and click. But sometimes you accidentally change it. You don't want to do that. You want real roots. We don't care about imaginary roots. And then we fill in what we got for our equation. The coefficients is what you're filling in. So attached to our x squared or n squared here, we have 1. Attached to our x, we have -3 because we're subtracting the 3. And then our constant is -130. Hit OK, or hit enter. And it gives us our 2 answers. If you plug this into nsolve, it looks just like that in nsolve pretty much, right? Except it'd be equals 0 or this equals 130. It would give you -10 because the absolute value that is smaller than 13. The way it works is it searches back and forth and just finds the quickest one. And -10 is not the right answer. So you have to use the polyroots. And again, that is menu, algebra, polynomial tools, find roots of a polynomial. That's where I click twice by accident, and you'll get here. You can also click find real roots. I'll skip that little... Oh, probably don't want that. But then it doesn't give you that little menu to fill out. So you probably want to stick with that other thing because it's a lot easier. All right. So in this case, n equals 13. Cool. I added this down here because I don't have it memorized. That's honest. That's my homework for y'all. Y'all can do it for me. What is the area of a regular pentagon with a side length of 12? So a pentagon has 5 sides. Side length is 12. So that's our S. That looks exactly the same. That's our S, though. So we're going to plug it all in and then just toss it in the calculator. So we got 5 times 12 squared is 144 over 4 times tangent of n minus 2. Oh my goodness. N minus 2, which is 3, because we have a pentagon, 5 minus 2, times 180 over 2 times n, which is 10. All right, so we're going to grab this and go in here. Now, mine is in degrees right now. If yours isn't, you can actually just scroll using this. I cannot scroll using this. Oh, I kind of can, actually. That's wacky. I had no idea. And then you click. You click. I assure you, you click. Anyways, if you click this, it changes. I checked on a real one. So you can click this, and you want it to say deg for degrees. And you can do that for at any time. It'll just switch this document. The default won't change, though. Radians is more useful. For right now, we want degrees. So we will plug this in. 5 times 144 over 4 times. And to get tangent, you can either type it out, or you can go hit trig, which is right below control, and then scroll over and choose tangent. And this is why we have to be in degrees. And we have 3 times 180 over 10. Enter. All right. So our area is 247.75 units. I just use generic units for all these problems. I think I put meters in a couple places. Generally, they'll give you like meters or centimeters, but it's not insanely important that you keep track of that. That's it for the polygons. I really do think that's mostly fine, except for this last bit. Might be challenging, but I think y'all can do it. Maybe just memorize it and write it at the top of your test right before you take it. If you're in asynchronous and you cheat and look it up, shame on you. Prisms. Surface area of a prism is this, all right? So that is 2 times the area of the base. And the reason I write it like that is because depending on what shape the base is, that changes, right? That the equation to find the area of it changes. So generally, it'll give you like triangular, rectangular prisms. If it gives you like a pentagonal prism, to find that area, you might have to use this. So double whammy. Might help you out regardless. Or find the area however best you know how. That's what you have to do. And then this PB is a delicious sandwich. It is the perimeter of the base, right? So let's say this triangular prism has, and this L is the length or the height. So the length of the face is being stretched from the base. So the area of our base, let's say this is A, B, and C. C is this long one. Our area of this triangle is going to be, because this is a right triangle prism, its base of the triangle, in this case this, times height. And since it's a right angle, we can just use these two things. We don't have to find some height like that. And that would be base times height over 2. So that's the area in abstract, right, of this here. The perimeter is, so this would be the area of our base. We need 2 of them because there's 2 bases. We're looking for the surface area. And we're going to add on our perimeter times the length is the lateral surface area is what it's called. And sometimes they'll just ask for the lateral. So you just need the perimeter and the length, and you can find that. You don't have to find the area of the base, but you got to be careful about that. So our perimeter is going to be A plus B plus C times our length we'll call L times L. So this would be the surface area of this triangular prism. This changes every time, as does this, based on the shape of the base. The volume is the area of the base times the length. So instead of all this for the surface area, our area would be AB over 2, area of our base, times L. That would be the volume of this prism. Okay, that's it for that. When we do cylinders on that for the last quiz, it's this exact same thing. It looks like more because I give you all of the equations for the area of a circle, and the circumference would be the perimeter of the base. So that looks like a lot. You'll see that in a second. All right. What is the volume of a prism with base area 32 meters, so we don't even have to find it, that is 20 meters long? And you'll notice this does not say what kind of prism it is. No triangular, no rectangular. It doesn't matter because they gave us the base area already. And if we needed the perimeter, they would give us that as well. Several of the questions don't tell you what type of prism it is. So the area of our base is 30 meters squared, 30 times our length, 20. So our volume is just 600 cubic meters. And these are meters squared and meters. If you care to keep track of your units, you'll see that it comes out to the meters cubed, which is a volume unit. That's pretty simple. What is the surface area of a prism where the base area is 60 meters squared, the base perimeter is 40 meters, and the length is 12 meters? So you'll notice again, it does not give us the type of prism, but that's fine. We have everything we need. So the surface area is 2 area of the base, is what I'm writing here. You could just say A. I think it makes more sense when I say it and add the subscript. Times perimeter, or not times, plus the perimeter of the base times the length. So we don't have, oh wait. No, this one's quite normal. Sorry, sometimes they'll leave out one of these, and we'll do that in a sec. I was thinking we were further ahead. We're not. 2 times the area of the base is 60 meters squared. Might as well keep that. Plus, and the perimeter is 40 times the length is 12. So we will go plug this in. We have 120, 2 times 60, plus 40 times 12, 600. So the surface area of this prism is 600, just like the volume of the last one, but it is in meters squared. Which again, if you're keeping track of your, those are both meters, they come out to meters squared. If you're keeping track of your units, it can help you figure out where you make algebra mistakes, but don't worry about it too much if you're not used to doing that already for like physics or chemistry. That's really the only places you really have to keep track of. You're forced to keep track of units. Find the volume of a rectangular prism with edge measures of 9, 11, and 13. So we could say area of the base times the length. That is the same as length times width times height in this case, which is probably, you've learned that for rectangular prisms. Imagine there's more stretching out that way, yada, yada, yada. This is length, width, height. You just multiply the 3 together because length and width give you the area of the base. So you don't have to think about it in these terms for a rectangular prism, but I just wanted to show you that it is the same. This is just already combined for the general formula. So we just 9 times 11 times 13 is going to equal our volume. 9 times 11 times 13. 1287 cubic units. Again, most of the time I don't bother putting the meters or whatever because you don't keep track of them anyways. So that's the answer to that one. Pretty simple. This one we need to rearrange our formula. Find the length of a prism with surface area 328 units cubed, base area 44 units squared, and base perimeter 20u. So we'll fill out what we have. 2 times, and we have the base area, which we normally put here. 2 times 44 plus, and we don't have the length. We have the perimeter, 20, but we do not have the length. So that's what we're solving for. Equals 328. This you can put in end solve, but honestly, just don't. Just do the math. This is 88. So if we subtract that 2 times 44, that 88 from both sides, we will get, I'm sure I can do that in my head, but I'm tired. We'll get 20 times L equals 240, right? And we divide that by 20, we get 12. So L equals 12. It is legitimately quicker just to do that algebra than potentially mess up the end solve syntax. Just when it's this simple, probably try and just do it instead of end solve. It's not a shortcut. It's a hack almost. Like you can go quicker for the simple stuff. Not that bad though. Find the volume of a triangular prism if its base is a right-angled triangle with leg measures of 8 units and 7 units and a prism height of 24 units. So I added this. It's kind of like what I did in the explanation preliminary slide. Because this is a right triangle, a right-angled triangle, this leg can serve as the height. With a non-right-angled triangle, the height is something like this, right? And and then this would be the base, but in this case the base is attached to the height already. So just let me talk about that more, drive that point really home. Anyways, this is 8, this is 7. So the area of our base, and we're looking for volume, so we got area of the base times height or length or whatever you want to call it. It's all the same thing. Say it goes way over there, there's more triangle here, blah, blah, blah. This is the height or the length. It doesn't matter. Really just relative to if you set it on its side. So 8 times 7 is 56. Divided by 2 is going to be, honestly, couldn't do that in my head right now. 28. That's the area of our base times the height is 24. It's going to give us our volume. 672 units cubed. Cool. And this 28 would be units squared, and this would be units if you care about that again. And that's all you have to do for that. This one just wants the lateral surface area. I think it's the last one before that, yeah. So, well, for the lateral surface area, that's the second half of this equation. Plus perimeter times height or length. So this is the bases. We don't want that right now. We just want that perimeter times the height. So the perimeter of this is 5 plus 7 plus 8 plus 9 plus 3. It's a pentagonal prism with very odd side lengths. So 5 plus 7 plus 8 plus 9 plus 3 is 32. Yeah, those are the right numbers. So our perimeter is 32 times our height of 15, or altitude. I added this because they will say altitude. It just means height and length. They're all synonyms. Cool. 32 times 15, 480 is the lateral surface area, units squared, is the lateral surface area of this weird prism. Not that bad, right? That's really, it doesn't get much worse than that. I think there's like one problem that's a little challenging, but y'all got it. And if you don't, again, in the future, after going through all the math, we will look at more advanced problems, because these really hard problems on these quizzes, you won't get questions like that until like the second or third competition at the earliest. So you want to focus on the base concepts before you start worrying about how do I inscribe a pentagon on the inside of a circle and find the unused area of the circle with the pentagon perfectly. It doesn't matter. Just get used to the easiest stuff first and then work your way up. Don't freak out because you didn't understand the harder questions, especially if you are like a freshman or sophomore. You haven't had the math yet. Don't freak out. Do your absolute best, but try and really get the ones that you know right correct. All right, so this is like the exact same thing. There's just more equations because the area of a circle is a little more complicated, and the types of problems they give you with it are more complicated for that reason. So the area of a circle, or the base, right, is so that's the same as that, pi r squared, r being the radius of the circle. Circumference of the circle is 2 pi r, or, and this is the same as the perimeter of the base, right? And this, you could also say this is pi times the diameter, because 2r is the diameter. But usually they'll give you radius. The surface area of a cylinder is 2 times the area of the base, right? Or 2 times pi r squared, because that's the area of our base, plus the perimeter times the length. In this case, our perimeter is 2 pi r. It's the circumference times the length. So you can see it's the exact same stuff. There's just more equations. The volume is the same, except for the area of our base has changed, and they'll pretty much always give you the cylinder length in height, or like altitude or whatever. It's all the same thing. So this is our base area. All the same stuff, different way to find those things. All right, find the volume. So area of the base times the height of a right circular cylinder. And right circular, they're all right circular. They just say that sometimes, so I wanted to put it so when you see it, it doesn't freak you out. It's not different. That literally just means that the base of the circle, wow. Anyways, the base of the circle and the actual sides meet at a 90-degree angle on the inside, like a can. Pretty much, like if it's not a cylinder like that, it's a chopped off cone, so you don't have to do that. It's silly. Find the volume of a right circular cylinder with a radius of 7 and a height of 13. So we need to find the area of our base, and that is pi r squared. Now, for pretty much all these problems, they say use 22 over 7 for pi. For this problem, we're not going to. I'm going to leave it in terms of pi, but then on several of the other problems, I'm going to show you, because you do need to do it, but you can get the concepts without doing it. You just have to multiply it in place of pi at the end. So pi r squared is 49. So 49 pi times our height, which is 13. So 49 times 13 is 637, and I'm going to leave that pi like that. So 637 pi. And then you would just multiply 637 times 22 over 7 to evaluate this, and it'll give you some long decimal thing. We don't need to do that right now. Pretty easy though, right? The lateral surface area of a right circular cylinder is 64 pi, and it has a height of 8. So the lateral surface area is just the perimeter, or the circumference, times the height. And our circumference is 2 pi r, and our height is 8. So 2 pi r times 8 is going to equal 64 pi. And then we'll just do the algebra here, because it wants the radius. That's what we don't know. So first thing, let's divide by 8 on both sides. You could divide everything at once, but I'll be thorough. 2 pi r equals 8 pi. And then we divide away the 2 pi from both sides. And those pi's are going to cancel, right? And so we're just left with r, and the whole 2 pi is going to cancel. We're left with r equals 4. And that is the final answer. So I was checking my notes to make sure I did that completely correctly. A cylindrical pillar, so it's another way of saying a cylinder, it looks like a can, is 2 meters in diameter and 9 meters in height. Find the cost of painting the lateral surface area, so only the lateral, we're not worried about the bases, of the pillar at the rate of $5 per square meter. And this one says use pi equals 22 over 7. So you do need to actually input 22 over 7. Don't leave it in terms of pi, because your answer choices won't be. So first we need to find the lateral surface area, which is the circumference times the height. Now, this says 2 meters in diameter. All right, so our circumference could just be pi times 2, but you have to keep in mind that this is not the radius, so don't multiply it by 2, or see that the radius equals 1 meter, and then subsequently do that. So you could say 2 pi r would just be 2 pi times the 1, but 2 of the diameter times pi is also the circumference, times 9. And that's our lateral surface area. But it says use 22 over 7 for this, So when we go plug it in the calculator, I will. 2 times, control divide, 22 over 7 times 9. That is the, in square meters, that is our area. Now, you probably want that in a better looking form, so you want to do control enter to get that, because we have to multiply it times $5 per square meter. And so it's just easier when it's not in a fraction. You could also do it once you multiply this times 5, because it'll have it in like terms of dollars and cents, not a fraction. So we just got to multiply that answer times 5. So the cost, rounded up to the nearest cent, is $282.86. Cool? Cool. The radius and height of a cylinder are in the ratio. This might be the last one. Yeah, because there are 2 questions like this. They're not that bad, but they are kind of annoying. This is like a systems of equations, but you cannot use the systems of equations tool, unfortunately, because it is not in easy linear terms. All right, I'll show you. So this is saying the radius and the height of a cylinder are in ratio 3 to 7. So another way to write that, how to write ratios, is radius to height is, or it equals, 3 over 7. All right, so the ratio of these is that. And the volume is 1584. So our volume is that area of the base, so pi r squared times the height, h. But we don't have any of this. So we need to solve for one of these things and then plug it in. And you can use nsolve for this, I believe, because well, you can, because it's not a quadratic equation per se. It's technically going to become a cubic equation, which nsolve can solve for. It's kind of confusing, but because this will come out to a third and not squared, there's only one real solution. So don't worry about that. You can use nsolve for this. This is going to equal 1584. All right. And so now we need to solve for one of the other of these things, and we want the radius. So I'm going to solve for r, which is the harder one to solve for here, but it'll give us our answer immediately. So we can rearrange. We can multiply both sides by h, and we'll get r equals 3h over 7. But what we really want to do is, well, I'll leave it as this, because it's not much harder. You could solve it the other way, where h equals 7r over 3. We'll leave it like this. It doesn't really matter, because you can solve afterwards, so don't worry about it. So then we can substitute our r with this. I don't know if any of y'all have done substitution yet. Well, some of y'all have, obviously. If you haven't, this is how you do it. Crash course. We're going to put this in here. 3h over 7 squared. All right. Times h equals 1584. And this will become a cubic. So we can put this into nsolve. We're going to replace pi with 22 over 7. Menu, algebra, numerical solve. We have 22 over 7 times, and then what we need to put it inside. Oh no, what did I do? Oh, I hold down control. Don't worry about that. Times, we need a divisor in there as well. 3, and I'm going to use x because it's easy to get to. 3x over 7 squared times x, right, equals 1584, comma, x, 14. So our height is what we solve for there. Our height that we solve for there is 14, right? So with that, let me scratch this out, our original equation, we can get r over h. We can replace this with 14. So r over 14 equals 3 over 7. Oh my goodness. I'm tired, y'all. That's a 7. And then you can see here, 14 is 2 times 7, so R needs to be 2 times 3. R equals 6. 6 over 14 reduces to 3 over 7. Hope that makes sense. That's all I have for y'all. There will be at least one question that is a challenge question. I would recommend writing even further this down and memorizing it in some way. I don't know what kind of things you got going on in your brain. Maybe the nutmeg times cinnamon squared over 4. I don't know what you got to do, but memorize this, because here's the deal. If you look it up during your test, you can't look it up during competition. So you're just setting yourself up to miss that question when it actually matters. Your class scores do matter. It's important to do your best because it affects your grade. So, if you care about that, it affects your grade. It does affect your rankings in the class. But I'll let you in on a secret. Your competition scores are the only thing that matter when it comes to making the team. So if you look it up when you're taking your test, asynchronous or whatever you're doing, if you're at home, or even if you're at school and you slip it in a little note in your hoodie sleeve, you're just shafting yourself. You're not gonna help yourself even in the short run. You'll get one more question right, 2, but you won't have it memorized, and you do need it memorized eventually. Good luck.